Well, I'm Hugh Ross. I'm the founder of Reasons to Believe. I'm trained as an astrophysicist, and I serve on the pastoral staff of a church sandwiched between Caltech and the Jet Propulsion Laboratory. And I'm bringing to you a special edition of Stars, Cells, and God, where I'm going to talk about a breaking scientific discovery that has important significance for the Christian faith. And this was released just a few days ago in these two rather thick preprints that were posted on the archive website. Both of these papers have been submitted to an astrophysical journal. I'm sure they're going to get published because 43 very prominent astronomers were involved in this. And it's basically their use of the James Webb Space Telescope. I'm sure most of you have heard of the James Webb Space Telescope, an amazing instrument. 7 times bigger than the Hubble Space Telescope. And for those of you that can actually are looking at a visual here, this slide shows you what the James Webb Space Telescope looks like. Believe it or not, it's only half the weight of the Hubble Space Telescope, but it's by far the most powerful optical telescope in use in the world today. And its primary mission is to give us some insight on the very early history of the universe, what's referred to as a cosmic dawn. And that's that moment after the cosmic creation event when the universe expands sufficiently that stars now can begin to form. This happens when, according to the Big Bang creation model, when the universe is about 200 million years old. Well, this first paper here basically used the near-infrared spectrograph on the James Webb Space Telescope to determine the distance to a galaxy that had been spotted in a previous image. And this next slide actually shows you a previous image taken from the James Webb Space Telescope, looking at very distant galaxies, very close to the beginning of the universe. And then you see that exploded subset there. That's a particularly bright and distant galaxy. And it was so bright that astronomers thought maybe we can get an accurate measurement of the distance to that galaxy. And that's what they did with the near-infrared spectrograph on board the James Webb Space Telescope. And what's the big breakthrough is it's the most distant galaxy yet determined by astronomers. They determined a redshift of 14.32. And that corresponds to a distance of 13.51 billion light years from Earth. And to put that in historical context, that means that astronomers are observing this galaxy. They were observing this galaxy when it was just 280 million years after the cosmic creation event. So barely after when it's theoretically possible, according to the Big Bang creation model, when stars can even begin to form. So the most distant known galaxy, that's what caught the attention of a number of bloggers on the internet. The James Webb found this most distant galaxy. And it was followed up, however, by the same team of astronomers in this particular paper, where they used another instrument on the James Webb Space Telescope, the mid-infrared camera. And their goal was not just to measure the distance to this galaxy, but the size and the brightness of this galaxy, because that's where you really get information about what's happening in what's called the cosmic dawn. And so, it took a long time, 24 hours of integration on the James Webb Space Telescope. That's phenomenal because telescope time on the James Webb is very dear. But they managed to say, hey, this galaxy has some real significance in being able to determine what's going on in the early universe. So they were granted at the time 24 hours of exposure on this particular galaxy. And they're able to measure the size of the galaxy and the brightness of the galaxy. And they were quite stunned with the size that they determined. Basically, that the diameter of the emission of light in this galaxy is a little bit more than 1,600 light years across. And the brightness of the galaxy was such that they realized the stars. Well, let me back up a bit. The fact that it was that big, 1,600 light years across, meant that most of the light from this galaxy was not coming from a rapidly forming supermassive black hole at the core of the galaxy. If that were really correct, you would see this galaxy as a bright point of light. But the fact that they saw an extended extent of light, 1,600 light years across, told them some of the light could be coming from the galaxy's central supermassive black hole, but most of the light was actually coming from stars. And the brightness and the size of the galaxy led them to conclude that the total mass of these stars that were responsible for the light came in at about 500 million times the mass of our star, the sun. And this is what caught the attention of a lot of people, recognizing this is a lot of stars that early in the history of the universe. And I actually notice some young Earth creationists immediately jumping on this and saying, this proves that the Big Bang model is wrong, proves that the universe is not billions of years old. Astronomers now need to admit to the public they got it all wrong. Well, not really. And this is something I wrote about earlier a few weeks ago on, this is part of my blog series, Today's New Reason to Believe. It's the most recent one. So if you go to reasons.org and just go to the blogs and my blog, Today's New Reason to Believe, it'll be the first one that shows up there. I think the date, in case I'm writing some more, it's April 22nd, 2024. But it was in this article that it basically talked about another galaxy that got a lot of attention. And it's a galaxy that had a redshift of 11 rather than 14. But still, we're talking about 400 million years after the cosmic creation event. And what I described in the paper, how they not only saw the emission from the supermassive black hole, the emission from the stars in the galaxy, but they actually saw a gas cloud in the halo of this galaxy 400 million years after the cosmic creation event. And they're able to show that there were no stars in that halo. And with a spectrograph on the James Webb Space Telescope, they determined that gas cloud was 100% composed of hydrogen and helium, which is exactly what the Big Bang creation model predicts, that the universe begins infinitesimally small, expands from that infinitesimally small volume, and as it expands, it gets cooler and cooler. But when the universe is less than 4 minutes old, about a quarter of the primordial hydrogen is fused into helium, and all the rest of the elements we see in the periodic table are manufactured in the nuclear furnaces of stars. So a major prediction of the Big Bang creation model is if we look sufficiently distantly away, we should find features where we don't see anything except hydrogen and helium. And the Big Bang also predicts a nearly trivial amount of lithium. The spectrograph wasn't sensitive to pick up the lithium, but they found nothing else. So this was a major confirmation of the Big Bang. But also the light they saw from this galaxy at redshift 11 was so intense that they concluded the stars in that galaxy have to be really massive. We're talking 500 times the mass of our star, the sun, upwards to 1,000 times the mass of our star, the sun. And the brightness or the luminosity of a star goes up with a fourth power of its mass. So if we're talking, 1,000 times greater than the mass of our star, the sun, that means a single star is shining with 1 trillion times the brightness of our sun. And so if indeed the first stars of form in the universe are these really massive stars, hundreds to 1,000 times the mass of our star, the sun, this would explain why astronomers using the James Webb Space Telescope are finding several galaxies that are exceptionally bright and exceptionally big, bigger than what we would anticipate if indeed the first stars were like 50 times the mass of our star, the sun, or 100 times the mass of our star, the sun. So these two papers that have been submitted to an astrophysical journal are basically affirming what I wrote about back in April, that indeed when we're seeing these bright as early galaxies through the observations of the James Webb Space Telescope, it's basically telling us the first stars of form in the history of the universe are indeed really massive stars, hundreds of times the mass of our star, the sun. that explains why we're seeing these bright galaxies so early in cosmic history. This is not a refutation of the Big Bang creation model. Actually, it's affirming a subcategory. And often lay people don't realize that we observational cosmologists have about a dozen different Big Bang creation models that are competing with one another. And that was really the mission of the James Webb Space Telescope, was to be able to image these galaxies in the first billion years of cosmic history and see which of these dozen plus Big Bang creation models actually correctly describes the early history and later history of the universe. And I remember long before the James Webb Space Telescope was sent up, astronomers were debating, are these first stars 60 times the mass of our star, the Sun? Are they 100 times? Are they 1,000 times? Are they only 20 times? And what are the numbers of stars being produced? This is what the James Webb Space Telescope is going to tell us. We don't have the final answer yet, but thanks to these two papers that have been submitted, we got a much clearer picture than we had even 2 weeks ago. Namely, more evidence that the first stars of form, at least a significant population of those first stars, are stars that are hundreds of times the mass of our star, the Sun. Now, the spectrograph, the near-infrared spectrograph that was taken by this team of 43 astronomers, what they also saw was what they call the Lyman break. And this next slide, the final slide I got here, basically shows you what astronomers call the Lyman break, the Lyman alpha break. It's basically a hydrogen line where you see this very significant break in the spectrograph. And it was that break that enabled them to measure the distance, because they measured the redshift of that Lyman alpha break, that hydrogen line break. And because it's such a stark distinctive in the spectrograph, even though the star, the galaxy, was very far away and hence quite faint, they were able to determine its distance to high precision. But that same spectrum that they took showed hydrogen lines and oxygen lines. The fact that they could see an oxygen line, they had a hint that they were also seeing maybe a carbon-3 line. It wasn't positively detected, but oxygen was, which tells them that's another piece of evidence that this galaxy had to have very massive stars forming the moment that stars could first form within the picture of the Big Bang creation model, namely about 200 million years after the cosmic creation event. And I mentioned earlier that the brightness of a star goes up by the fourth power of the star's mass. That also tells us that the more massive the star, the faster it burns up. And a star that's more than 100 times the mass of our star, the Sun, it'll go through all of its nuclear fuel in less than 1 million years. And if we're talking 500 to 1,000 times, it literally goes through it within a few 100,000 years, which means that the star is fusing hydrogen into helium and making heavier elements. So the fact that we see oxygen and maybe a hint of the carbon tells us there's been at least 2 generations of star formation in the first 80 million years after which stars are able to form. But if we're talking stars 500 times more massive than the star, the Sun, you can have not only 2 generations, but even 3 and 4 generations of such supermassive stars forming. So I would actually explain why we're seeing elements besides hydrogen and helium that early in the history of the universe. Now, this doesn't rule out the possibility that you're getting small stars forming at the same time. In fact, that's what we see when we look at star formation later in the history of the universe. You get very massive stars, you get mid-sized stars, and you get small stars. But these observations are basically telling us we're getting hundreds, if not thousands, of these really massive stars. And it'll take future observations of the James Webb Space Telescope to actually give us any insight. Okay, what about the smaller mass stars? Are they forming at the same time as the bigger mass stars? This is more challenging because, say, stars the size of a star, the Sun, they take hundreds of millions of years to form. And smaller stars could take up to 1 billion years to form. And so, which means these small stars get thoroughly polluted by the really big stars before they even begin to ignite their nuclear fusion. But this is the goal of the James Webb Space Telescope. And these two papers are exciting, and finally we're nailing down why we're seeing these exceptionally bright galaxies so early in the history of the universe, and why they're measuring to be hundreds of light years across. And so I'm looking forward to what else the James Webb will discover. And really what we need to wait for is when the James Webb not only does a 24-hour exposure, but will do exposures that last several days. That will enable us to see the smaller mass stars and the clusters of smaller mass stars that may be forming at that time. And when we find that, that's going to actually pinpoint even more exactly what kind of Big Bang creation model we're looking at. But this stands as stronger evidence for the Big Bang, not weaker evidence, and basically is telling us which of these family of Big Bang creation models is the correct description for the universe in which we live. And this has been the history of the Big Bang. I mean, if you go back 100 years ago, they were saying, well, it looks like a Big Bang. Then they said, it's not a cold Big Bang, it's a hot Big Bang. They were able to determine the rate at which it was expanding. And then they realized, okay, it's a Big Bang model where most of the stuff of the universe is dark energy, and the second dominant component is cold dark matter. And now astronomers are trying to look at that dark matter, determine is a little bit of it warm or is it all of it cold? Hopefully the James Webb will help us to discern that as well. And finally, I'd like to mention, next year, 4 telescopes, radio telescopes, are going to be robotically placed on the backside of the moon. And those 4 radio telescopes are going to be able to do something no other telescopes have been able to do. And that's actually make astronomical observations at wavelengths greater than 30 meters across, very long wavelength astronomy. And it's that very long wavelength astronomy that's going to give us insights on the cosmic dawn, because it'll actually give us an idea about what's happening when indeed the very first stars form, and what is the date in the history of the universe for when the very first stars form. James Webb is not going to be able to give us that, but these telescopes in the backside of the moon will, which means we can look forward to getting a really precise picture of the history of the universe. And how this impacts the Christian faith, keep in mind, thousands of years ago, you had Bible authors, 5 different Bible authors, speaking about the fundamental features of Big Bang cosmology, how the universe has a beginning that includes the beginning of space and time, how the laws of physics that govern the universe are unchanged. They've remained fixed. How one of those laws is a pervasive law of decay, which means we expect entropy to increase as the universe gets older and older. And 11 passages in the Bible talk about the stretching out of the heavens, the expansion of the universe. So long before astronomers discovered the Big Bang, Bible authors in the Old Testament were speaking about the Big Bang. Job, the oldest book in the Bible, says that God alone stretches out the heavens, basically crediting God and saying this is a supernatural event. And indeed, as we observe the Big Bang universe, we see it's got incredibly fine-tuned cosmic features that speak of the supernatural handiwork of the Creator. It explains why the Big Bang model, when it was first proposed in 1925, elicited really furious rejection, because the astronomers at that time who were not believers said, this looks too much like what the Bible teaches, and this is philosophically repugnant, in the words of Sir Arthur Eddington. But the more we observe the universe, the stronger and stronger case we get for what the Bible taught thousands of years ago. I'll be posting notes and 6 research papers that accompany this. So if you look at the notes of this posting on our YouTube site for Stars, Cells, and God, you'll be able to dig into it to all the detail that you would like, because both of these free prints are available for free to the public. Well, thank you, and I look forward to engaging you with other breaking discoveries on the frontiers of science. Go to reasons.org And definitely subscribe to our YouTube channel and be alerted to when we release new editions and episodes of Star Cells and God. Thank you.